Lesson C7, piecewise defined functions. If you were looking in your textbook, this would be in Lesson 5.8. The standard is FIF7. Here are the I can statements that you're looking at. I can represent a piecewise function with a table or graph by evaluating several values of x, and I can graph a step function by substituting in values of the plots. So I want you to look at this graph and how different it is. It says a function can be in pieces. So you can create functions that behave differently depending on what you input for x. So this has three different pieces to it. This is a function here. Remember, each input has an output, one output. It passes a vertical line test. All of these pass the vertical line test because at this point your graph is either here or up here. It's not going to have both of those, and you'll see what I mean by that as we look at the rest of the notes. So if we are watching this video, and I'm going to put this video on for you so you can watch it, I want you to complete the following definitions. Piecewise functions given by different blank on various, and by model which equations are included. So as you are watching this, look for those couple of things. Here is our video coming up.
How do you graph a piecewise function? In this lesson, you will learn how to graph piecewise functions by using your knowledge of graphing other functions. Let's review. When we graph, we have any kind of input. We have to use open circles and closed circles. A closed circle is filled in. You will use it if you have less than or equal to, greater than or equal to, or an equal to. Basically, it has to have the bar underneath the inequality sign. When you have a closed circle, that means that the point is part of the graph. You can also have an open circle that is not filled in. You use this if you have greater than or less than. And the point is not part of the graph. We have a piecewise function. The definition of piecewise function is given by different expressions on various intervals. So, if we look at this, this is actually two functions put together. That's why it's piecewise. The first function is f of x equals negative x plus 1 when x is less than negative 1. The second one is f of x equals 2x when x is greater than or equal to negative 1. So if we have an x of 0, we would plug it into the second one because 0 is greater than negative 1. So f of x would be 2 times 0, or 0. So it depends what your x value is, which equation you plug into. These are called the expressions for the function. And we have constraint. A constraint is a limitation or a restriction. These are the constraint intervals. We want to graph our piecewise function. The first thing we do is to graph the first part of the function, which is f of x equals negative x plus 1 when x is less than negative 1. This is the graph of the function. F of x equals negative x plus 1. We had our y-intercept at 1, so we started there, and then we had a slope of negative 1, which is down 1, right 1 from our y-intercept. But like this. Now this has a solid dot at the end because it has the equal sign. It's greater than or equal to negative 1. So negative 1 is part of this graph. So that gets a solid filled in dot.
I want you to make sure you take a look at this graph and that you're understanding.
X equals negative 1. And this is the part of the graph that we want to keep, the part that is less than negative 1. We do not want this part of the graph. So that leads us to a graph that looks like this. We keep the part that we want to keep. We have an open circle where x equals negative 1, And this is because there is no bar or equal to as part of our inequality.
So again, as you're looking at this, making sure you're understanding that this is because of the less than, that it's open, and only that part going less than that value.
We want to graph the second part of this function, which is f of x equals 2x when x is greater than or equal to -1. There is the line f of x equals 2x. There is where x equals -1. We want the part that is greater than -1, which is this part of the line. And we do not want that part. So that yields us a graph that looks like this. Now this has a solid dot at the end because it has the equal sign. It's greater than or equal to -1. So -1 is part of this graph. So that gets a solid filled in dot. The final graph is a combination of the two. We have our first one, which was the -x plus 1 when x is less than -1. And here is our second one, which is 2x when x is greater than or equal to -1. This is our final graph. Common misunderstanding occurs when you do not use the constraints. We have the equation y equals -2 if x is less than -3. The constraint is x is less than -3. Here's the equation, or the graph, for the function y equals -2. But we have the constraint, so this is not the correct graph. The correct graph looks like this. It is where x is less than -3. It has an open circle because the point -3 is not part of this graph. In this lesson, you have learned how to graph piecewise functions by using your knowledge of graphing other functions.
We want to use that now. So if we were filling in our words, the words you should have filled in as we are looking at this. Piecewise functions, if we are looking at that, are given different expressions and on various intervals that we are looking at. To model this equations, you should have had, we are looking at the constraints which limit it. So as you continue going through the video and taking your notes, making sure you understand that. So we have special piecewise functions that are sometimes defined. Sometimes you're going to see something like this. So it says a taxable amount. So various taxes are defined with, this is how much tax you're going to be taxed, 1 cent, 2 cent, 3 cent, okay, on a dollar, depending on the amount. Here's another piecewise function, absolute value function if we are looking at. So these are just different ways that we have broken into pieces. This is our one piece where the slope is -1 and the piece where it's not -1, where it's a +1. So when you look at these different piecewise functions, a lot of times you might see if you go to the post office, they're going to charge you a different amount depending on the weight. They are going to charge you up to 39 cents for that first one, up to 1 ounce. But when it hits 1.1, you are going to be charged 41 cents. So it's an open circle here to a closed circle at 2. And that continues going up. That would be a step function or piecewise. In this one, very similar to the graph, notice they have an open circle or a dot at 0, 2, y equals x plus 2, a solid dot at 0, 0 because f of x for x, and it was greater or equal. And again, as you look at this last one, this is the equation up until y is, if we were looking at that, y is, or x is less than this value here. Then they have a 6. They have 3 different functions here. So as we look at that, so piecewise functions can be written many different ways. The ones that we are going to be looking at graphing is going to be very similar to the one with the postage stamp, and that's what we're going to do in these next 2 examples. It says the cost of renting a mountain bike for 3 hours, if we are looking at that, at a rate of $5 is $25 for the first 3 hours and $5 for each additional for the first 3 hours. If you use that part of if you use only part of an hour, they prorate it. on the $5 per rate, hours per rate. Write a graph of the piecewise functions and think about the cost for T hours. So the first thing we kind of want to think about is, what is our cost? Well, the first one is y is going to be equal to 25. It is always going to be 25 for 0 between x and up to 3 hours. The second one is a little trickier because we've already done that 3 hours. So it's our slope is, and we still have to pay that $25, but it's plus the slope or rate of change of x, and this one's going to be written a little differently. We can't just put in x because we can't use 0, 1, 2, or 3. So we're going to put this a little differently, and we're going to put it as x minus 3. And this, our constraint, will be when x is greater than 3. So if we put in 4, we know it will cost us $30. We can't put 1, 2, or 3 in because they're going to be on this graph. So if we are looking at this, what does that look like? Well, they're charging us $25 for the first 3 hours, right? If we go from there, now our slope is 5. So I'm going to go and notice if I look at my numbers on the side, my scale here, this is our cost in dollars, okay? And if we were putting a label down here, we would probably need to put our hours. And if we wanted to put our title of the bike, title of our graph, it might be renting a mountain bike. Rates. So that we're kind of thinking about what this is. So notice here, we said we're going to have a slope of 5. That means we go up 5, but oh, this is 5 and this is over 1. So at 4 hours, it would cost us 30. At the next one, if we go to 5 hours, it's going to be costing us $35. And we would have this going with a line, okay? Make sure if you need to pause that to look at it and to think about it. And this might be the trickier part. Don't get stressed out about it. We'll go through more like that. The ones you're really going to see more of is this step function like this one. So as we look at problem 3, it says the amount of income tax for a single tax owes the United States upon her incoming each year. This table shows the tax brackets for different levels of income in 2012. Graph the function. So first off, we need to think, from 0 to 8,500. That is going to be, if we look at this, this is 100,000, so this would be 20, 40, 6. If we are going across, we would be looking at 0. And then we have, as we are looking at this, we have to have that first one for 8,500. That's going to be really small right in here. That is at our 10%. So at 10%, we're going to have closed circles on both of those. That's a really small amount. But when you get to 8,500, your tax bracket jumps up to 15. So if we are looking at this, this would be 10, 12, 11, if we were going up to 20, so we'd have 12, 14. So it's going to be right in the middle here is going to be our 15%. Okay? So if we're looking at 15%, they're telling us that it's going to go from 8,500 up. So I'm going to show you the graph in just a minute, and then you can kind of see what that looks like. The reason I wanted you to pause it is the video is almost out of time. But I want you to notice this was our 15%. 25% is going to be, again, right in the middle there, 25. And it's an open circle at the 34 up to the 83. Open circle at the 83,600. Notice these two are the same amounts. To a closed circle. Open to a closed, going from our 174 to 379, and everything above 379 is going to be taxed at that 35%. So if we were looking at that. So this is what your graph looks like. I want you to try the next one on the next page. Think about making the graph of going on a bus, and you will probably see this on the next video.